Online Microeconomics Exam Help. For any help regarding microeconomics homework help, visit www.economicsexinghelp.com/, email support@economicsexinghelp.com or call us at +1 678648427. A principal hires an agent at date 0. At date 1, the agent will face one of two tasks, task A or task B. Neither the principal nor the agent knows at date 0 which task the agent will face at date 1. It will be task A with probability P and task B with probability 1P. The agent will learn the task at date L. The principal will never learn which task the agent faced. The agent's effort into either task is private information. The agent's cost of effort when performing task A is CA, E is equal to E2, and her cost of effort when performing task B is CB, E is equal to A plus B2, where A is a parameter that can be positive or negative and B is positive. The principal's benefit from task A is B, E is equal to E. The principal does not benefit from task B. The principal and the agent are both risk neutral. The principal and the agent observe a signal of effort X is equal to E plus epsilon, where epsilon is a Gauss term with zero mean. Given risk neutrality, the specific distribution is unimportant. The signal X is observed regardless of which task the agent is performing. The principal pays the agent with a linear contract S. Kiss smiley is equal to alpha X plus. The agent's reservation utility is normalized to 0. The fixed payment can be negative. A. Set up the program that selects the Pareto optimal parameters and given the agent's incentive compatibility and participation constraints. Note that effort levels are different depending on which task the agent ends up performing. B. What is the optimal value of C. Suppose the principal can rule out task B. If task B is ruled out, X is identically 0 when task B would have come up. Task A still comes up with probability P. Problem. Will it ever be optimal not to rule out task B? Consider a monoxonistic firm facing a continuum of workers. These workers can be of two types L and H with 0 L H1. The fraction of workers of each type is PL and PH. Workers of type I that are paid wage W and asked to work H hours receive utility. U is equal to U, WA, where U is a strictly concave increasing utility function with U, 0, is equal to 0. The hours of work H must fall in the normalized interval 0, 1. Both type of workers have U, 0, as their opportunity cost of working. The value to the firm from hiring a worker of type I at wage W and hours H is equal to HIW. The workers know their cost parameter I, the firm does not. A. What is the profit maximizing first best contract in this situation? I.e. when the firm can identify the two types and offer separate contracts to each. Can this contract be implemented? Being set up the program that identifies the profit maximizing second best solution. C. Use a diagram to identify binding constraints. Characterize the solution to the second best program as precisely as you can, utilizing the diagram if you wish. One can give an exact answer. D. When will the low type not be hired at all? Question 3. An agent produces output for a principal according to the production function Y is equal to E plus, where E greater than or equal to 0 is the agent's choice of input, and is a stochastic productivity parameter that takes on the value H with probability P, 0P1, and the value LH with probability 1-P, I0 for I is equal to L, H. The principal can only observe the output Y, not the input E nor the productivity parameter. The agent can observe before choosing his input X. The agent's utility function is U, M, X is equal to MC, kiss smiley, where M is money and C is a strictly convex and increasing cost function with C, 0, is equal to 0. The principal is risk neutral and values profit. That is the difference between output Y and the payment to the agent W. The principal offers the agent a contract W, Y, which the agent can reject or accept after observing the value of. The agent's reservation utility is the same in either state and is normalized to 0. A. Set up the program that maximizes the principal's expected profit subject to the agent's incentive compatibility and individual rationality constraints, participation constraints. The dots show that only one of the individual rationality constraints and one of the incentive compatibility constraints will bind. You can provide an algebraic or a geometrically based argument. C. Assume now that 0, 1 is a continuous parameter. Write down a formula for W that implements the first best choice function E** for the agent. Hint, for each type the agent can be viewed as choosing Y rather than E. It is easier to consider Y the agent's choice variable. Question 4. Consider the following regulation problem. A firm produces a public good with the cost function C, X, is equal to X to 2, where X is the output and is a cost parameter that only the firm knows. The social benefit is B, kiss smiley is equal to X. The government has to decide on an optimal incentive scheme for the firm. If P, kiss smiley is the payment for X, the firm's profit is P, kiss smiley, C, X. The firm always has the option not to produce, which yields profit 0. A. Suppose the government wants to maximize the sum of social benefits and the firm's profits. Show that in this case there is a simple subsidy scheme that maximizes the government's objective and thus achieves the first best outcome. B. Suppose instead that the government is only interested in maximizing the social benefit B, kiss smiley net of the payment P, kiss smiley to the firm. Assume the cost parameter can take two values, is equal to 1 and is equal to 2 with prob, is equal to 1, is equal to P and prob, is equal to 2, is equal to 1. P. Set up a program that solves the government's second best problem. Draw a diagram that shows the nature of the second best solution, including the constraints that are binding, the level of firm profit, and the second best distortions in the choice of X. C. Assume now that is continuously distributed on the interval 1, 2. Suppose the government wants to implement the solution X is equal to 2. What payment scheme should it use given the objective in part B? Solutions. A. Here is the program. The first constraint is the agent's I constraint for task A, the second his I constraint for task B, and the third his participation constraint. The optimal alpha is thus: when alpha A, EB is equal to 0, and the principal's payoff is. The optimal value of alpha is 1. When A1, the principal's payoff is increasing in alpha when alpha greater than or equal to a PB plus 1P and decreasing in alpha when alpha greater than or equal to A. Therefore, the optimal alpha is A. To sum up. C. Assume that B is ruled out. Consider the following contract. Alpha is equal to 1 and beta is the minimum salary that satisfies the agent's participation constraint. Then EA is equal to a half and EB is equal to max A to B 0, which are first best effort levels. In other words, there is no efficient